Hello, welcome back to Algebra. The title of this lesson sounds very intimidating, but it's not. It's called Solving Equations and Inequalities with Fractional Coefficients. This is part one. We're actually going to have several parts here where the problem complexity gradually increases. So what do we mean here? In the last several sections, we've done lots and lots of what we called simplifying complex fractions. And that's just a fancy way of saying in the previous lessons, we've had these gnarly, really complicated looking fractions with lots of expressions on the top and the bottom of the numerators. And so we have to go step by step to simplify those. Now we're going to take those skills and begin to solve equations that are a little bit more complex than what we've done in the past. You know, a simple equation like 2x plus 3 is equal to 10, you know how to do that. You move the 3 over, then you divide or multiply, whatever needs to be done to get the variable by itself. So that's all true even in these equations. But in these equations, we're going to have what we call fractional coefficients. That means in some equations, in front of the variables, like in front of x, for instance, you might have fractions, 1/2. You might have fractions on the right-hand side, 3/4. And so what ends up happening is you solve these equations in basically the same way, but because you have these fractional coefficients in front of the variables, then it just becomes a little harder because to add or subtract anything, you have to deal with all the fractions. So what we're going to do is start with an easy problem with these fractional coefficients. I'm going to show you how to solve it two different ways, actually. The first way will just kind of get you understanding what we're doing, and then the second way will actually be how you're going to tackle most of these problems because it ends up being a little bit easier. So let's just jump right into it, and you will see as we do enough of these that the process is very easy to understand. So for our first equation, it might look something like this. Let's say we have x over 9 plus 1/6 is equal to 2/3. Now, really, the only reason that this equation is a little more challenging to solve than a regular equation in algebra is because of all the fractions. Notice you have something with the x variable, you have the 9 on the bottom, plus a number, but this number just happens to be a fraction, equals another number, and this number also happens to be a fraction. So the first step to get x by itself is just to move the 1/6 to the other side. But you see, when you do that, you're going to end up having to subtract fractions. And if you don't have common denominator, that means you'll then have to find a common denominator, then subtract the fractions. And it's just a little bit more challenging than the simple problems we've done before, like 2x plus 3 is equal to 7. You just move the 3 over, divide, multiply. Since it's all just numbers, it's very simple. But when you have fractions, you have to deal with the fractions, right? Now notice we have x over 9. I want to point out to you and just make sure you understand that this is exactly the same thing as 1/9 times x plus 1/6 is equal to 2/3. So in your book, if you see an equation like this is exactly what we said. It's an equation with a fractional coefficient. The coefficient here is 1/9, that's a fraction. Here you have a fraction, here you have a fraction. So this is an equation with a fractional coefficient because the coefficient, which is what's in front of the x here, is a fraction. Now, of course, if you consider x to be x over 1, and you multiply the tops and multiply the bottoms, then you're going to get x over 9. So this x over 9 is exactly the same thing as 1/9 x. So how do we solve it? As I said, there's two main ways. The first method, I'm going to call it method 1, and that's just to basically do it what I'm going to call the brute force way. That means just do everything normally like you would typically do to solve an equation, adding and subtracting and dividing and so on, but you're just going to have these fractions that are going to be in your way. So let's go ahead and do it. What you're going to find out is it's kind of like causing you a lot of extra work, but there is a simpler way which we will discuss after we do it this way. So let's call this, I'm going to call this method. This is the only time I'm going to solve these twice. This is method 1. I'm going to call it brute force. What I mean by that is you just pretend you don't know anything about this equation. You're going to solve it exactly the same way as we've solved all the other ones. We want to get x by itself, so we have to subtract the 1/6, right? So if we subtract it from the left, we're just going to have x over 9 left over. But if we subtract it from the right, we'll have 2/3 minus 1/6. See, we subtract 1/6, that makes it 0 here. Subtract 1/6 from this side, and there you go. Now, unfortunately, subtracting fractions, it's not so easy in your head, right? So you have to then get a common denominator. So what I want you to do then is to say, well, let's go ahead and just work on this kind of separately here. If I have 2/3 and I'm subtracting 1/6, I want to like to try to find a common denominator. Now, the easiest one I can find is a 6. So what I'm going to then do is I'll just take this fraction, multiply by 2 on the top and the bottom. That way I'll have a 6 denominator. So then what I will have is 4 on the top, 6 on the bottom, minus 1/6. right? Now I have a common denominator, so 4 minus 1 is 3, again, out of 6. And you should all know you can divide by 3, and you're going to get, when you simplify this, 1/2. So even though it doesn't look like it, 2/3 minus 1/6 actually equals 1/2. And you have to go through all this. And I'm choosing simpler fractions. But still, you should see that no matter what the fractions are, you're going to have to manipulate it and get it into the simplest term. So what we have really done is we now have this equation, which is x over 9 is equal to, when we did all this, we said it was 1/2. And then we ask ourselves, how do we get x by itself? Well, we have x divided by 9, so in order to get it by itself, we multiply by 9. So just to refresh your memory, if you have x ninth, if we multiply by 9 on the left, then we'll have 1/2. We'll have to multiply 9 on the right. Of course, now the 9's cancel. So on the left, all you really have is multiply here. This is 9 over 1. Multiply the tops, giving you 9. Multiply the bottoms. You have an implied 1. Here you have a 2. So the answer to this is 9/2. Now, of course, you can put this into an improper fraction, mixed fraction if you like, or you convert this to decimal if you want, but this is the exact answer. It's 9/2. If you take 9/2 and put it in here, I'm not going to do it, but if you put it in here and you cancel the 9s, you have to add the fractions again, you're going to get 2/3 once you stick this number back in here. So that's what I call the brute force way. All of these equations that what we have called fractional coefficients can be solved just pretending that you're just doing it the exact same way you solve any old equation. Subtract a fraction, maybe multiply a fraction. You're just trying to clear everything out to get x by itself. So in this case, we just subtracted the 1/6, then we multiplied by 9, and there you go. Now, that's method number 1. Method number 2, we're going to do over here. So I'm going to call this method 2. And what I'm going to call this is we're going to try to clear denominators. Okay? And we're actually going to do this a couple of different ways too, because it's important for you to see. The original equation, I would like to rewrite it again over here, just so we have a clean slate. X ninth plus x over 9 plus 1 over 6 is equal to 2/3. All right, so the reason this equation is difficult to solve is because of the fractions, right? The fractions have numerator over denominator. So you can multiply an equation by any number you want. You can multiply by 50, you can multiply it by 972.5. Doesn't matter. You can multiply by -10, as long as you do it and multiply to both sides. When you multiply the equation on both sides, the equation, even though it might look different, actually is completely in balance, like a seesaw. It's still in balance, so it represents the same thing. So if I multiply this equation on the left by 2, as long as I multiply on the right by 2, the equation might look different, but it will have the same solution. I can multiply the equation on the left by 17. As long as I multiply the right by 17, it will have the same solution. So what we want to do is, let's be clever. Let's multiply the left and the right by something that will get rid of some of those denominators before we even start solving it. Because really, if the denominators are gone, then you don't have any fractions anymore. And if the fractions are gone, then it becomes a real simple problem to solve, just like the basic equations we've done a long time ago. Then we don't have to do the fraction arithmetic, but we have to clear the denominators first. So here, let's pick something. Let's just go through it. Let's clear some denominators. Let's multiply the left and the right-hand side by 9. Right? You're going to find out that this isn't the best choice in a second. But for now, let's just say we multiply by 9. Why am I picking 9? Well, because if I multiply by 9 over here, 9 divided by 3 will give me 3. So that'll clear the 3 out over here. If I multiply by 9 over here, then 9 over 9 will be 1. So I'll clear the 9 out over here. So let's just kind of do it and see what we end up with. Let's go over this direction. Well, let's work underneath. Let's say we're going to multiply the left-hand side by 9. Now, when you multiply an entire equation by something, you need to wrap the whole equation up like this, because you're multiplying the whole left-hand side by 9, and then the right-hand side is 9 times 2/3. Now, you all know that 9 is 9 over 1, right? But I'm going to write it as 9, okay? So because we're multiplying the entire left by 9, we need to distribute this 9 to both terms in here. So what you end up with is I'm going to write it as 9 over 1 times x over 9. That's multiplying times first thing, plus 9 times the 1/6. I'm going to write it as 9 over 1 times 1/6. Writing it as 9 over 1 is not necessary, but it kind of helps me visualize what I'm doing. And on the right-hand side, of course, you have the 9 over 1 times 2/3. Now let's see what we've done. Let's see how clever we have been. On the right-hand side, of course, we can multiply them first and we can then simplify, but we have a 9 and a 3, and we know now when we have fractions multiply, we try to simplify first. So 3 divided by 3 is 1. 9 divided by 3 is 3, right? Over here, 9 divided by 9 is 1. 9 divided by 9 is 1. They cancel. Now over here, it's not perfect, but we can still divide by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. I'm still able to simplify it some. So let's move along and see what we have. Here I have an implied 1, an implied 1, and a 1, so really all I have is x. Notice by multiplying, I've completely eliminated the fraction. I only have x left. Here I have 3 times 1, 2 times 1. So I have a fraction 3 halves. And here I've canceled, I only have 1's on the bottom, so they multiply to give me 1, and then 3 times 2 is 6. So you see what I've done? By multiplying this equation by 9 on the left and 9 on the right, I've transformed this equation into a new equation. This equation looks completely different than this one. However, they will both have the exact same answer for x. Why? Because sometimes equations can look different and have the same answers, just like fractions can look different but mean the same thing. 1/2 of a pizza is the same thing as 5/10 of a pizza, which is the same thing as 3/6 of a pizza, which is the same thing as 10/20 of a pizza, right? They all look different, but they mean the same thing. This equation looks different, but the same solution for x in this equation will be the same thing as the solution in this one, because when I multiplied by 9, I did it to the both sides. So we can then do this. We can solve it. We'll switch back here to black. How do we get x by itself? Well, we subtract 3 halves. So we subtract it from the left, it means it goes away. On the right, we have to subtract 3 halves. Unfortunately, I still have some fraction arithmetic to do, so let's just do it here. What I will do is I'll say 6 over 1, and I have 3 halves here. So then I want to get a common denominator, right? So I'm going to use 2 as a common denominator, multiply by 2, multiply by 2. So then what's going to happen is I'm going to have 6 times 2 is 12 over 2 on the bottom, minus 3 halves, right? 12 minus 3 is 9, and on the bottom you have 9 halves. So what we found is that x is equal to 9 halves. 9 halves is the answer. That's exactly what we got the other way. So we've manipulated the equation. We've changed the equation, but in a totally legal way. And by doing that, we were able to eliminate the denominator, basically eliminate the fraction here, giving me just a number. Eliminate the fraction here, giving me just a number. Unfortunately, I didn't eliminate all the fractions. I still had one left over, so I still had to do some math, some fraction math. So that wasn't perfect. But at least I got at least some of it kind of eliminated. But then at the end of the day, I still ended up getting the same answer. Okay, so that's called solving first by clearing the denominators out. Now, those of you I know watching this can see right away, probably most of you, that we were pretty clever, but we weren't perfectly clever. There's a better number to multiply this equation by than 9. 9 clears this fraction because 9 over 9 is 1. 9 clears this fraction here, the 3, because it divides out. But 9 was not able to clear this one out because we didn't pick the best value. So let's go do it. I know it's kind of boring, but let's go do it one more time. And we'll be a little bit more clever here. What if we have x over 9 plus 1 over 6 is equal to 2/3? In the previous example, we multiplied by 9. Now let's think, is there a better number we can multiply? Some number so that when I divide by 9, it goes away. When I divide by 6, it goes away. And when I divide by 3, it goes away. And of course, there is a better number. There are actually lots of better numbers. But let's use the number 18. Let's multiply the right-hand side by 18. Why 18? Because I know that 18 divided by 3 is just 6. I know that 18 divided by 9 is 2. And I know that 18 divided by 6 is 3. So when I multiply by 18, not only will I clear this fraction and this fraction, but I will also clear that one. So let's just go through it real quick. We have 18 over 1 times multiply in x over 9 plus multiplying this one, 18 over 1 times the 1/6, distributing it in, equals, and then over here we're going to have the 2/3 times the 18 over 1. So then I can grab my red pen and say, well, 9 divided by 9 is 1, and 18 divided by 9 is 2. I can clear the 6. 6 times 3 is 18. And then over here I have a 3 and an 18. 3 divided by 3 is 1. 18 divided by 3 is 6. So now I'm going to rewrite the equation again in light blue. I have 1s, implied 1s, everywhere in the bottom of all of these denominators. So really all I have now is 2 times x, multiplying the tops, plus 3 times 1 equals 2 times 6 is 12. Now look what we've done. We've taken our original equation in black, which was difficult to solve with fractions, adding and subtracting and multiplying fractions, and now we have a very, very easy equation to solve. Just subtract 3, 2x equals, what is 12 minus 3? That's 9. And then x will then simply be 9 divided by 2. We just divide by 2. Boom, the answer is 9/2. Now, I agree with you that in order to get to the simpler equation, right, the one that's easy to solve, we had to do something first. We had to, what I like to say, we had to beat that equation into shape. We had to put it into a form that was easier to solve, right? But to be honest with you, that's a really common technique in math. It's common in algebra. It's common, very, very common in calculus, in advanced math. Many times we have equations in calculus and other advanced math that you just can't solve unless you change the way it looks into something else that you can solve. Right? So this is your first exposure to that. We just want to be clever. So in the rest of these problems, I'm going to give you a choice. You can, of course, solve all of these fractional coefficient problems by the brute force method. You can just subtract the fractions, multiply, divide fractions. That's no problem. Of course you can do that, right? You'll get the answer. But if you're clever, then you will always be able to multiply the left and the right-hand side of the equation by some number that clears all of those denominators away. And then it's very simple to solve. And you have to go through some work there in the beginning. But I don't know about you, but I would much rather do this than a bunch of fraction arithmetic, like adding and subtracting. All right, so now that we have the basic idea out of the way, we can now solve a different problem. So I have two more problems, and I think I'm going to have enough room. I'm going to go over here, and I'm going to start the problem kind of over here. Now that we have the basic idea out of the way, it's going to be very simple to continue. Let's say we have the equation 2 times t minus 1, all divided by 6, equals t plus 2, all divided by 4, plus 1/3. Of course, you could do this by the brute force method, right? In order to do that, you would have to break up this fraction into two fractions. You have to break this one up into two, and then you'd have to add and subtract all the constant fractions, and then you have to move all the fractions that have t involved to this side, and then you would have to divide and so on. So it's a lot of work. But instead of doing that, let's multiply left and right by something that makes it easy. So let me, instead of marking this up, I'm going to say 2t minus 1 over 6 is equal to t plus 2 over 4 plus 1/3. And now what we're going to do is decide what are we going to multiply by. So we need to multiply the left by something and multiply the entire right-hand side by something. We have 6, we have 4, we have 3. Roll those numbers around your head. 6, 4, 3, 6, 4, 3. What number could I pick that if I tried to divide 6, 4, or 3 into it, it's going to give me an even number? I mean, I can't pick 10, for instance. If I do 10, then 10 divided by 6 doesn't go evenly. You would think I could pick 8. If I multiplied by 8, 8 divided by 4, that's great. But 8 divided by 3 doesn't really work, right? And so on. So I just continue to go up, up, up. I get to 12. 12 divided by 6 goes evenly. 12 divided by 4 goes evenly. 12 divided by 3 also goes evenly. So I'm going to multiply this guy by 12. Because I know that when I do that, I'm going to clear every one of these denominators. So then in the next step, I want you to get in the habit. A lot of students will write this down, and then they'll start marking through it and trying to do it all in this step. I don't want you to do that. I want you to write the next step. The next step is multiplying. Here I'm going to write it as 12 over 1 multiplied by 2t minus 1 over 6. I'm not going to do anything yet. I'm going to rewrite it because this 12 has to be distributed into both terms. So you have 12 over 1 times this fraction, t plus 2 over 4, and then the 12 times the 1/3 plus, write it as 12 over 1 times 1/3, like this. All right, then once I have that in place, I can start marking things up. 6 divided by 6 is 1, 12 divided by 6 is 2. 4 divided by 4 is 1, 12 divided by 4 is 3. 3 divided by 3 is 1, 12 divided by 3 is 4. And now that I have all of that in place, notice I have 1 times 1. The denominator of this fraction will be a 1. 1 times 1, so I'll have a 1. 1 times 1, I've cleared them all. So here 2 times, again, don't do too many things at once. Write it like this. 2 times the 2t minus 1. Don't do the multiplication yet. Equals 3 times, you got to write it with the parentheses, t plus 2. and then you have 4 times 1. I can just go ahead and write that as 4. You want to be careful to wrap these things in parentheses because you have to distribute the 3 in. When you say 3 times this term, you have to distribute it in. 2 times this term, you have to distribute it in. So in the next step, 2 times 2t is 4t, minus 2 times 1 is 2, equals 3 times t is 3t, plus 3 times 2 is 6. Then I have the plus 4. All right? So let me simplify the right-hand side. 4 times t minus 2 is equal to 3 times t plus 6 plus 4 is 10. Now I need to move the t terms. Let's take the 3t, subtract it from both sides. So 4t minus 3t is t. Let's leave the minus 2. Let's leave the 10 for the next step. All I've done is subtract the 3t. That disappears from the right. Subtract 3t, giving me t. These terms stay the same. Now I move the 2 over. T equals adding 2, 12. So t is going to be equal to 12. That's the final answer. So, you know, when you learn equations for the first time, you usually write all this down, that you're subtracting 3t, and then adding 2 and adding 2. And as you solve more and more equations, you don't have to write all that. You know that you're subtracting 3t, so it subtracts and gives you t. You know that you're adding the 2, so it disappears over here and you're adding the 2. Now, I know that you're looking at this and you're saying, well, this still seems like a lot of work. But you're going to have to believe me, the only other way to solve this thing easily is you'd have to break apart this fraction, the 2t minus 1 over 6. You have to break it up into 2t over 6 minus 1 over 6. And then you'd have to break this one into t over 4 plus 2 over 4. And then all of the fractions that were just numbers, you'd have to add them on and get them all on one side. And all of the fractions that had a t involved, you'd have to pull them to the other side. But every time you add those fractions, you have to get common denominators. Then you'll have to either multiply or divide. And when you do that, you'll get exactly the same thing. But it's easier to clear the denominators out and then get yourself to a very easy equation to solve. Boom, you can get to the answer. All right, we have one more just to kind of bring it home, solidify things here. And that's going to go as follows. What if we have z divided by 4 minus z minus 1 over 6? Now it's not going to be an equation, it's going to be an inequality, less than or equal to 5/12. A lot of times students will look at this and they'll say, well, it's an inequality there, and then the head will explode. They'll have no idea what to do. Remember, when you're solving inequalities, you just pretend it's an equal sign effectively, right? And you basically leave that arrow in exactly the same orientation as you solve your problem. And you use all the same rules of algebra as if it were an equation with an equal sign. But if you multiply or divide the left or the right-hand side of that inequality by a negative number, then you have to flip the sign or the direction of that inequality. But if you don't multiply or divide by a negative number, then you don't change the orientation of the arrow at all. So in order to do this, we have, again, 4, 6, and 12. And let's see here. The last one was 6, 4, and 3. We chose the number of 12 to clear it. It turns out that the number 12 will also clear this equation because 12 divided by 12 is 1, 12 divided by 6 is a nice number, 12 divided by 4 is a nice number. So it just worked out that way. In reality, different problems will have different numbers. So let's go ahead and rewrite it. We're going to have z over 4 minus z minus 1 over 6, less than or equal to, I keep the same orientation, 5/12. And then what I'm going to do is I'm going to multiply the left-hand side by any number I want, but I'm going to pick 12. I multiply the right-hand side by the same number, 12. So in the next step, go ahead and rewrite it explicitly. This 12 has to be distributed into each term. So you write it as 12 over 1 multiplied by this fraction z fourths. Minus, because of this minus, the 12 gets multiplied in as 12 over 1 multiplied by z minus 1 all over 6. Keep the less than or equal sign from here, and then the 5/12 can be multiplied by the 12 over 1. So now that you have it all written explicitly like that, it's very simple to say, all right, 4 divided by 4 is 1, 12 divided by 4 is 3. 6 divided by 6 is 1, 12 divided by 6 is 2. And then, of course, the 12 and the 12 cancels. You divide by 12 in each case, and they just go away. So then, all of the denominators of every fraction is just a 1. So on the top, I have 3 times z, which is, as you know, 3z, minus from here. Here you have a 2, but you're multiplying by this fraction by the entire thing, z minus 1. So you have to wrap that in parentheses. Don't forget to do that, or you'll get the wrong answer. Less than or equal to, and then the 5 times 1 here is just going to give you 5. Next step, we distribute in, and it starts to look like a regular equation. Minus 2z plus 2, just multiply here, give you negative 2z, multiply by here, give you positive 2, less than or equal to 5. 3z minus 2z is just 1z plus 2 less than or equal to 5. And then we move the 2 over by subtraction, so z less than or equal to subtract 2 here, 5 minus 2 is 3. So z is less than or equal to 3. Notice we did not have to change the direction of this arrow because we never multiplied or divided this thing by negative 1. In future problems, we might have some reason, we'll get to it when we get to it, where we have to multiply or divide by negative 1. In that case, we'd have to flip the direction. But in this thing, z less than or equal to 3 is the answer. So all numbers less than or equal to 3 satisfy this, because when you take any number less than or equal to 3 and put it in here, it will always be less than or equal to 5/12. So that's what that means. Okay. So in this lesson, we have introduced the concept of what we call solving equations and inequalities that have fractional coefficients. A fractional coefficient is when your variable involves the coefficient in front of that variable is a fraction. And I showed that more clearly in the first problem. Usually you'll see it written as x over 9, but that always can be written as just a fraction times the variable, so the coefficient is a fraction. Anytime you have fractional coefficients, you have a choice. You could manipulate the equation by just adding or subtracting those fractions and solving it usually like we did, but it's almost always going to be simpler to try to clear the denominators out by left and right hand side like we've done. So make sure you can do all of these problems. I would call these problems easy to slightly towards intermediate toward the end. And then the next lesson, the next several lessons, will increase the complexity gradually to give you more practice solving more and more difficult equations that have fractional coefficients.